Okay, so this is the video on how to do a basic regression, linear regression in SPSS. I am going to use the CARS data, which is the same data set that is used in the slides on slides 27, 28. Well, your slide numbers are actually going to change, but this is this example here with the car rental companies. So the book did this, the Blumen book rather. They got a correlation of 0.982 by hand, and then they actually calculated the slope and intercept by hand, and they got 0.396 and 0.106. And so they came up with the regression model by hand. Now in regression, we actually write things backwards from what you're used to. Y equals mx plus b typically in algebra class. We call, to make your life really, really confusing, we call the slope b in statistics and we call the intercept a. So, and we reverse the order from mx plus b to a plus bx. So b here is the slope, and that's 0.106. That's the incremental change in, if you increase, for other cars, if you increase by 1 unit of cars, that's the increase in revenue. So it's a unit change. And then the intercept is 0.396, and that would be, it's effectively nonsense in this case. And you can see that this line here doesn't actually, they truncate the line so that it doesn't actually go through the 0, 0, because realistically, talking about revenue when there's no cars is that's what the intercept here would be doing, and that's just fictional. But it's a mathematical entity, and sometimes the intercept has no meaning. The slope always has a meaning, but the intercept may or may not. And so this was this example 1011. It does come from the Blumen book, and they actually they're just plugging in values here, so that's not an issue. But yeah, so I'm going to reproduce this in SPSS is what I'm going to do. Okay. So I typed in the data, hopefully correctly, I think so. And it's called CARS Reg Model. I'll put this on Canvas for you as well. And so there's just 6 companies, and then there's cars and revenue. So we're predicting revenue based on, I believe this is cars sold, I don't know, I forgot. It doesn't actually say, by the way. I'm assuming it's cars sold, but I'm not sure. Help. Okay. So anyways, we're predicting revenue based on this car number, whatever it is. And we're trying to reproduce the example from the Blumen text. So the first thing I'm going to do, like I said, I'm not going to be a hypocrite. I'm going to take my own advice. I am going to do a scatter plot of cars and revenue. Now I know that revenue in this case is going to be my y variable, because revenue, it's kind of clear that that's something we want to predict. So I'm going to be consistent and do that as y. So I'm going to pull up my, I just pulled up the basic scatter plot. It was under graphs, scatter plot, and I'm just going to do a basic scatter plot. I only have 2 variables, so I don't need to do like my fancy matrix. And I entered y as revenue and x as cars, and I just want to quickly first run a scatter plot to look at my data. And this is my data. Okay. Again, I mean, this is a really, really minuscule data set. It's, you know, you would never in reality want to do a regression model based on 6 data points. I would say 20 is an absolute minimum. Even that is probably weak. But I have a feeling they might have just made this data up. I'm not sure. I can't really accuse them of that, but sometimes books do that. Yeah. So this is the scatter plot of the revenue by cars, and you can see that there is in fact a linear trend. I mean, this point up here to me seems a little bit possibly an outlier, but we talked about influential points. In a small data set, this would be, you know, kind of an influential point because it is dragging the line, you know, further up here. If this point were down here, it would like create a slightly different line, but you know, it's the overall pattern of the data that matters, and there is clearly a positive trend going on. Okay, so the next thing we want to do is we want to measure our correlation coefficient and test its significance, which we will do under Analyze, Correlate, Bivariate. And again, there's only 2 variables. Interesting, I haven't run this before and it's already selected for me. I didn't know we did that. And so we have our 2 variables, and we're going to do a Pearson correlation coefficient, a 2-tailed test of significance. That's really all we need for this. I don't need the covariances or anything for this. And so hit go, and we're going to get 0.982 as our correlation between cars and revenue, and this is highly significant. It's a very strong correlation value, and this corresponds to the value we saw in all this stuff. These slides right here, and just double checking, 0.982, yes, in fact. They did do the hand calculation on the slide, which you could follow if you so desired. I mean, if you're going to be a math teacher or something, it's probably worth your time. And so that's how this value came about, this 0.982, and that's the correlation. So now that we have a significant correlation, we can proceed into a regression model. If this were not, if this significance and two-tailed, if this were not below 0.05, we would quit. And that's really like one of the examples of really bad statistical practice. Another one of which is making models based on small data. But you can't really make a model if you don't have a significant correlation. I mean, you know, there is no relationship to model. So I think that's basically common sense, but you wouldn't believe how many people do that. Okay, so I do have a strong correlation, and I do have a significant correlation. So I'm going to go ahead and I'm going to do a regression model. And the way that we're going to do that, now this is where things are going to get a little bit wilder in this class. You're going to go under the Analyze menu, and there's just a whole bunch of different things. There is something called a general linear model. Don't do that for now, okay? That is actually an expansion of regression, as is generalized linear models. So now your life is like, oh my God, there's like all these things that look like what I'm doing. And they are actually related. Most of this is beyond the scope of this class, but there are a whole bunch of other model techniques in here. And so we're going to go down, and we're going to go to the regression linear, okay? So this is what you want to do, the regression linear, okay? Regression linear, write that down, because unlike some of the other things, there's a lot of things that look like this. And then hit go, and then you're going to get this, and yours isn't going to have them filled in. I did run this once, did I? Yeah. Anyways, and so yours will look like this when you pull it up. It's going to be this blank screen, and you're like, oh, look at all these nice things. So what we want to do is we want to put our dependent variable in. That's going to be revenue. The dependent variable is what we're predicting. It's our y value. So in this case, it's revenue. And then the independent variable, the x, is the cars. Okay. For now, all this other stuff, don't worry about. We are going to play with some of it very, very soon. But for now, just ignore it and just run this basic model with the dependent variable revenue and independent variable cars and hit go. Okay. And we get all this, and you're like, oh my God, what is this? Don't worry about variables entered, removed for now. We don't need that. We don't really need this model summary, but as you can see, one of the things in the model summary that's being repeated is this R right here is the correlation coefficient. So don't worry about the other things in here for now, but that's the correlation coefficient. The ANOVA table, we're going to talk about ANOVA later on in this course. For now, ignore it. You might know what that is, but you might not. And so what we really want is under regression, this thing, the coefficients. Now, there's a couple things in here. This thing is the unstandardized beta, and this is what we're going to use. These are the values that you're going to use in your regression model. The one that says constant, this is the intercept, and then this is the slope, okay? So you have the 0.396 and the 0.106. That corresponds to these values here, okay? That's your A and that's your B. So you have your intercept and you have your slope, okay? So this right here is how you would create your model. So you would do y prime, and that's revenue. I actually prefer models written in like the variables rather than x and y. So this is revenue equals 0.9 or 0.396 plus 0.106 times the cars, which is the x. And you can see in SPSS these values here under this unstandardized B. These right here are your main concerns when you do your regression model. Like the correlation, this is also testing. So we're testing the significance of the slope, which is significantly different from 0. This is sort of a redundant test with the correlation significance and sort of not. But right now, all you need to be able to do is read off the correct intercept and slope from this coefficient table from the regression output. And so it's the 0.396 for the intercept and the 0.106 for the slope, that will get you your A and B to do your basic linear regression model. And that's the basics of a linear regression model. There'll be a little more, don't worry, but that's the foundation. At least look at the scatter plot, look at the correlation, make sure the correlation is significant. You have to do that every time for regression. In this case, we kind of already knew, but when you're doing a regression and you're starting with new data, look at the scatter plot, look at the correlation. If the correlation is not significant, stop yourself, quit, say no regression model. And that's okay. Like on a test, if you don't have a regression model, don't make me one. Right? If your slope's not significantly different from 0, you don't have any strong relation to model. Okay? And so, but if you do have a strong relation to model, you can go ahead and you can do your regression. Make sure you enter your dependent and independent variables correctly. Let me just show you that one more time. So we're going to do that under Analyze, okay? And we're going to do it under Regression Linear, okay? There are a whole bunch of other things in here because SPSS does a lot of modeling stuff. You could make those coronavirus models in SPSS, by the way. But that's probably a little beyond this class. But so the basic linear regression, again, the dependent variable goes here, the independent variable goes here. I'm not quite sure why. Oh, actually, I am, because you can make functions of this. This one stays usually when you enter stuff in SPS, it's gone. And so that's your basic model, and just run this one. You will get more output, like this we don't need. This we really don't need, although that is the correlation again. The ANOVA table we don't need. And what we do need is under the coefficients. Now, coefficient, if you remember from algebra class, like you'd have 2x squared. 2 was the coefficient of the x squared. That's literally what these are. Right? So you have the coefficients, which is your intercept, and your slope, which is, of course, the coefficient of your dependent variable. Okay, so that's the basics of the linear regression model in SPSS.